I didn't know Postgres could do that. There's going to be code. You can sit in another room, apparently. The weird trick is if you want to take notes, you only have to write down the one thing where the logo pops up. And let's get on to the first thing. Now, most of you probably know what pgstat statements is. Everybody has heard of this, I hope. The reason I still mention this, so pgstat statements, I think, is available on like every cloud database provider, service thing, packager, whatever. But the thing that's like kind of wild about pgstat statements, everybody thinks that they know it. What most people don't seem to understand is you actually have to run the create extension command to get it in your database, right? So even if you're a database provider, and I've known a few that like offer this as an extension available, but they don't run the command for you. So if you think you're collecting this data and you've never run this in your database, you have to actually run the create extension command. So the first thing to know, hey, I didn't know Postgres could do that. I didn't know you could have these modules and not have them installed. It's totally true. You can. So even if you know about this, again, just remember that you have to actually run it. If you've never heard of pgstat statements, it does stuff. See, some of you now realize, damn, I should have sat closer because he's going to like put some really small font on there. You don't actually need to know all this stuff. So this is just like, here's all the columns, right, of data that are available. And this is in PG 17. So actually this slide would have changed because there is a bunch more information there than used to be. Like every year, I think we add a few more just to make this slide harder to read. So that's great. I'll give you probably a more useful example. So here's like if I took a row and I said, here's some actual data that's in there. So like a user ID is like, who's the user that ran the query? Database ID, right? What database is it in? Postgres internally tracks queries. It gives them like a query ID. How many times was it called? Right, so the query here is select all from actor where first name equals $1, but what it actually means is it's actually parameterized the query. So if somebody's asking, you know, first name equals Joe or whatever. And so Postgres parameterizes this within pgstat statements, and then a bunch of different like execution time and stuff like that that's on there, right? And how many rows you got back and that kind of stuff. So there's all this kind of useful information you can get. It can be overwhelming if you want to like point out to people that they should have sat closer because there's going to be code and they might be not able to read your slides. The main point of this slide is actually not that there's a bunch of information that could be overwhelming. It's just to say that it collects all this data in what is basically like a normal table. It's technically a view, but basically like a normal table that you could query with SQL and do all the fun stuff that SQL can do, right? So you can do aggregates and sums and analytics and all that kind of stuff. I would also mention there's a lot of tools that actually believe that you're going to have this in your database. So if you use a service like PG Analyze, it expects to be able to get data from this table. So you may want to have it for that reason. But it's nice to have it if you want to be able to do any kind of analysis on the queries you're running and the execution time. So I usually try to mention this out of the gate. Again, mostly because it doesn't come pre-installed. It's just like automatically available in most cases. So I like to make sure people are aware of that. So that was weird trick number one. How's everybody feeling? Like we were all comfortable with pgstat statements? All right, that's good. Let's see if we could throw people off with transactional DDL. How many people have used transactional DDL? Yeah, a few of you. I figured must have. So what is transactional DDL? Well, if we all remember the basic concept of transactions, databases really like them, or at least the relational ones do. Can't speak for those other guys, but so transaction is this idea, right? We're going to run a begin, and then we like type in our SQL. If it's all good, or I guess in this case, if it's all horrible, because I did a rollback, if it's all horrible, I can always roll it back and undo whatever SQL I've done, right? So that's the basic idea of a transaction. Postgres takes that one step further. What it actually allows you to do is things like this, where you can actually start a transaction and do like a drop table, and the table goes away, and then if you roll that transaction back, the table magically comes back. If you were to do this in other databases, I can't guarantee how it would work, but I would guess you probably will be sad. The typical way that I think most databases handle this, like I think SQLite does it the way Postgres does it, or it tries. There are other databases that may be really expensive that like if you type begin and then drop table, it will like issue an implicit commit with your DDL. And the table will be gone, and then you'll hit rollback, and you'll type in rollback and do that, and it'll be like, you're not in a transaction. And you're like, what just happened here? That's really awful. That's like the worst experience. If it would like throw an error, right? They're like, hey, you can't use DDL in a transaction. That would be phenomenally better. But no, we don't do that. So in the Postgres case, this will actually work, right? And you might think like, is that actually useful? What can I do with that? There's all kinds of things you can do with that. One of the things that you probably shouldn't do, but people love to give this example. So I'm giving this example, which is what you can do is start a transaction. You can create an index on your table and then run explain analyze on the query. And only that session will see this index. And then you can see, does it actually help me or not? If the index doesn't help, you can roll it back and the index goes away. And isn't that magical? That don't actually do that. Like I hear that example, I'm like, these are people who don't ever like they don't have operational experience. So probably the right thing to do if you care about that use case, create the index concurrently. Let's see if it actually helps anything, and if it doesn't, just drop the index. It's not, there's no blocking and all that. In the transactional version, there actually is some blocking that will happen if you do it that way. So don't, like I said, don't do this. This is not the use case. It will work, but it's not the use case you're looking for. Explain analyze does not update the statistics because it's explain. Yeah. Okay. Okay. So here's the use case that you want to use. So the question was, do I repeat the question when it's like never mind and don't whatever? Okay, they say I have to repeat the question. So Mark Wong asked whether explain analyze would update statistics when you're in a transaction. And I was like, dude, no, it doesn't do that. Seriously, you can ask that? I should have said Jacob. That would have actually been better. Sorry, Mark. Anyways, yeah, there you go. Okay, so here's the use case that you actually want to do. So we would do something like you start your transaction, you create a table, and then you create like additional tables that are going to reference that table, right? And you like sort of package those changes together. And so if you think about like when you're doing migrations, you have an application, it needs, one or more different SQLs to be run to like update the schema for the new version of the application. The nice thing is if you combine all of those into the transaction, then what you end up with is, either all of those will be committed and it'll all go together, or if there's an error for some reason, maybe you have an update statement in there or something and you run out of disk space or whatever, like the whole thing rolls back. So you basically have the ability to do an atomic change across multiple objects and know exactly where your schema is at the end of that. Right. And so then your application knows what version of the schema it has to deal with things. Without doing this in a transaction, if you run into an error like halfway through, now your schema is left in this like half broken state. Right. And that's sort of no fun. So this to me is like one of the really nice use cases for this is packaging that stuff together, especially if there's updates involved and that kind of thing, and being able to do it as one atomic change. You can take it even further though, because I like to push boundaries a little bit. People have noted. So here's another way you could use this. You could do something where you start a transaction and maybe you want to change a column from like family name, right? It's like what we used to use that term. Now we would say last name because we're Americans and names don't mean anything. After you do that DDL change, you can run a save point on your transaction. And that gives you a point where you can go back to this point or you can go back to the very beginning. So you could then put in like some test data just to make sure it's going to work, run some SQL that your application is going to run, verify that SQL does actually work, and put in whatever data you want to be able to mock up and change. Once you're happy with the results of those changes and that DML statement, you can then actually roll it back to just the part with the schema changes that you want. And that basically throws away all the test data that you put in there, right? Or if it went horribly wrong, you could roll back the entire thing. But in this case, what we're doing is we're rolling back just to let's keep the DDL. That actually worked and we like that. And then we'll commit the transaction, right? And this throws away all the mock data that we put in there. So you can actually do like some more advanced testing and whatnot if you're packaging things up and running it this way. So this is where sort of give you some ideas of like, here's how we can kind of stretch these features out and make them work. All right, insert returning. Who here is super familiar with the returning clause? I see some people aren't sure. They don't trust me. They're like, I know what this means in other presentations. I'm not sure about here. Okay, so this is not rocket science yet. So here's a very simple SQL. Imagine I wanted to be an actor someday. This Postgres thing hasn't really been working out for me. So I say to my agent, let's be an actor. So I insert it into the actor table, first name, last name, and then values Rob Treat, and return everything. And what that does for me is I do the insert just like a normal insert, but then Postgres is actually going to give me the row back that has just been inserted. And you will note that I only gave it 2 fields worth of data, and I got 4 fields back because I said return star, which is kind of like select star. That's an argument for a different bar. But I do return star to say, give me all the rows back. And it gives me the ID number that was automatically generated. It gives me the timestamp of the update. Right, and I get all that back. I don't have to know it. Now, in most cases, without using returning, usually you get some kind of like identifier back or something. I have to go back and query the database to get the information based on like an ID field. But this sort of like saves you that extra round trip. That's not earth shattering, but it's a little bit of a nice feature. Especially if you're in like sort of sharded environments where like you're going to do an insert and then you have to select back, and people sometimes they run these problems where like, well, did the data actually get to one of the read nodes? And it's like, you don't have to worry about that because we'll just return it back right off of the insert, right? And then I get whatever columns are coming with it. So we can do that for insert. Obviously we can do it for update. Maybe my acting career would work better if I were more serious and I went by Robert instead of Rob, get those dramatic roles. So I can do an update on the actor table and set the first name equal to Robert, where the actor ID is 202, which I got from the previous slide. And instead of returning star, let's say I just want those 3 columns, right? I already know the ID, so I don't really need those. So you can actually specify whichever columns you want. It's very much like a select list for a normal select statement, right? You can do some level of math and expressions on those columns and return back whatever piece of information you want. And again, like you don't have to do these multiple round trips. Like you can just do it all in one thing. And let's be real, like I have a face for radio, so I'm not going to be an actor. I'm going to get rid of that get rid of that row of data. So I delete from the actor table where last name equals treat, and I can do returning star on that, and it gives me, here's the row you just deleted. And this is actually, I think, my favorite one. I think it's the most like sort of overlooked, which is like if I had run this query where last name equals treat, and maybe I get like 2 rows back, right? Or like I get, like Postgres would tell you how many rows you get, but you'd like to actually see. I could get 1 row back and maybe it was the wrong row. Maybe I like mistyped my name or something because I'm that good at computers. And so I delete the wrong row. Like at least I'd have a shot at being able to put the data back in if I had to, right? But I think just like that last little ability to like verify, hey, you actually deleted the row that you wanted to delete. I love that about delete returning, and I think it's often very overlooked. So I like if I'm on PSQL, I definitely do try to do, if I'm doing deletes, I'm always like, let's return that data and take a look at it just to be sure it's what I thought it was. And so this is all nice. This is a feature. I think some other databases do have this, but not very many, which may be a feature if you're thinking about how do I write application code that cannot be ported to some other database, right? Like this is the kind of feature that will help you with that, if that's what you're into. I'm not saying you are, but anyway, so CTE returning. How many people are suffering from CTE? No, that's not what I meant. So CTE, there's a term, okay, CTE returning. So CTEs in the database world is common table expressions. And you will note there's a little thing in the corner. So if you wanted to know what the heck is this guy talking about, and you wanted to look this up later, sort of the official, quote unquote, the official name for this is a common table expression. In Postgres world, we typically just refer to them as CTEs. You might also hear in other database communities, they will be called with queries, like WITH. And you will see why in 1 second. But common table expressions is the name that's in the SQL standard. And you will see that name and that style of query in other databases, hopefully. There are a few different ways to do this, but that's what you would want to go look up, and that'll get you there. So let's look at a CTE. Let's imagine I want to see all the actors who are not actually good at their jobs, but we're not allowed to say that, who have failed to have their skills utilized by employers because capitalism. And we're going to get a list of them, and we'll call them underemployed, right? They're not being taken full utilization of. So I could do that as a CTE. So what I do is I just kind of name this object, right? This is my common table expression. I'm going to call it underemployed as, and then I'm going to run a query which is pretty straightforward, right? I'm going to select all from the actor table where the actor ID is not in, select actor ID from film actor. So if an actor has never been in a film, he's underemployed. He should do more work. And in this case, right, then I select back from the CTE that I have named underemployed. Just give me everything back. I get one record. It's Tom Miranda. His ID is 42. That's totally a random coincidence. I don't really have anything to say about that. So you might be looking at this and say, like, I don't know how useful that actually is. I'm questioning many of my choices, how I've ended up where I am at this very moment in time. And this is not actually super useful. If you had just run the query that's in the middle, I'll go back a slide. You're not supposed to do that, but I'll do it anyways, dang it. If you just run this, you'd get the same row back, right? So that's not the useful part. The useful part is when I go forward on the slide and I say, let's try something like CTE returning. It's a little more complicated, but I'll walk you through it. So I'm going to name a CTE and I'm going to call it RIP because this is going to be movies that have never been rented. And I just want to give those movies away, right? Nobody's going to pay me money. I might as well give it away. It's like open source. So with RIP as, and then I put my query in, delete from the inventory table where the inventory ID is not in the list of IDs that I select from the rental table. But I'm putting that returning star in. So if you remember, right, when I do a delete returning, I get all the rows back that I'm deleting out of the system. That's really useful because I can then take those rows and insert them into my giveaway table, right? So I do that insert into giveaway, select all from RIP. RIP was my common table expression. Some people like to say, I'm not really one of them, that like when you do the CTE, it kind of creates like an in-memory table. It does kind of like do that. With the data that goes on in the CTE. So it's very much like selecting that back out. So we insert that into the giveaway table, everything from the RIP, and we also can do a returning on that piece, right? To say, I'd like to see those rows that I have just deleted both from the inventory table and then stuck into the giveaway table, which actually in this case, it's only one row because business is good. So that's the kind of thing that like, you can really start to see how you put some of these things together. And when we talk about like, you can save like one round trip, like in this case, like you're probably saving 3, 4, 5 round trips, maybe, I don't know. Like if you were going to do this individually, you'd first like do a select, right? To get the ones you want to delete, then you delete those. And then I don't know how you'd capture that. So hopefully you saved it from the previous query. Then you do your insert, right? And then you kind of got to verify all that. And you'd want to wrap that in a transaction anyways, because you wouldn't want to have it in the giveaway and in the inventory still. If you do it this way, it's one statement, right? It's one round trip. It goes in, does all it's got to do, comes back and tells you what's up. You don't have to deal with transaction management. If something goes wrong anywhere in that process, maybe your insert, again, like runs your database out of space or whatever, doesn't matter. Like the whole thing rolls back and you're back where you started. Everybody's happy. So this is the kind of stuff that I really think like, oh, I can do some really good stuff with this. And I think it makes your application code a lot easier, you know, as you're sort of writing these things out. Certainly if you're doing scripting and that kind of stuff, again, I think it just makes it a lot easier to just bundle all that stuff into like one query, does what it needs to. Transactions are all taken care of. All right. How are we feeling out there? Everybody's good? All right. Range types. You didn't see that coming, did you? Anybody ever used range types? Nobody uses range types. They're fantastic. Well, they're interesting at least. All right, range types. Imagine I have a table, a rental table. The way we would normally do it, so this is, y'all look kind of old. So rental store, right? Like you go to a store, rent a video, take it home, watch it, take it back. I know, it's not Netflix, right? Like that's, I mean, it's not Amazon Prime. You actually have to physically rent it and give it back. So, rental date, in this case, would be the day that the movie was rented. Return date would be the day that the movie was returned. That's pretty straightforward. That's how you would have done this in the past. But the new hipster way, or as I like to call it, the Portland way. The Portland way to do this, so actually, I think it's true because Jeff Davis worked on this. I think he lived in Portland when he did this work. So this really is the Portland way. Okay, so the Portland way to do this would be to do an alter table on your rental table and add a column rental period. And this is going to use this magic TS range that we have highlighted here, which essentially means timestamp range. And we're going to do a range of timestamp values, or a range, yeah, of timestamps. You'll see in a second. So we'll contain that. We'll put timestamps in a range and put that in a data type in the table. Totally makes sense. We have to populate that data if we were to do it this way. So we would update the rental table, set the rental period equal to, and we can use this sort of constructor function that Postgres gives us on timestamp range, where we pass in the first part of our range, which is the rental date, and the second part of our range, which is the return date. And it will go update all the rows and give them a timestamp range. All right. And so now we've got both of those columns are stored within one column of data. And you're just like, that is the most fantastic thing I've ever seen, except for you in the back, because you can't see it because the font's too small. Should have sat closer. So it does look very similar, right? Rental date, return date, and then we have a range that shows both of those same dates. And you're like, I'm not sure that's actually mind-blowing. You know. But you can now actually ask very interesting questions with very little syntax. It's little syntax. Might be hard to remember, but it's very little syntax. So let's say I want to know, how many movies did I have rented on June 21st? I don't care when the rental started. I don't care when the thing was returned. I just want to know how many movies were rented on June 21st. In database parlance, we'd call this like a contains query. Air quotes, contains. This is actually really easy to write with the range type. So we can do select count from the rental table where the rental period, June 21st. The hard part is remembering that this little bird thing is the actual, that's what that means. It means contains. I think it's like there's a group and then the thing is like a embracement maybe. So that's the contain, I don't know. It's like a bird thing. That's what I think it is. So it's a very easy query to write and look at. You could work this out, obviously, if you had the two different dates with like some form of greater than, less than, right? Ignoring certain pieces. I don't know. But it's much easier to just write this thing and get the answer back. And this is what like these range types start to enable. And I should mention, you know, range works for like numbers. You can even do it with like text columns, which makes much less sense. But like dates and numbers are where it really shines. We can actually flip this query kind of on its head. If I said like, how many movies did we rent during the month of June? And again, like, I don't care when the rental started or if it ended after the month of June. I just want to know during the month of June, if a thing was rented, like I'd like it to be in the list. So that would be like select count from the rental table where rental period, and then that's like double ampersand thing. Again, that's the hardest part is to remember. But it actually turns out those are all documented. So it's really not that hard to remember if you just remember they're documented. Or you ask your AI and say, I'd like you to hallucinate two random characters and see what you think that operator means. Hopefully it gets it right. I don't know. I haven't tried that. But, and then you could pass in this TS range constructor again and say, here's the range that I'm looking for, from June 1st to June 30th. And then Postgres kind of does all that magic behind the scenes of like, okay, there's some overlap between the individual ranges for all those rows and this range that they passed in, and anything that overlaps, like I'm going to give you back that as part of your count, right? So it just makes asking those kinds of questions much easier. And you can actually take this much further. You can do a whole talk on this. I believe like two people who've done a number of talks on this feature, Jonathan Katz has done a bunch of them, and Jeff Davis has done a number of them. They were two people that are like really involved in actually putting this feature into Postgres a couple of years ago. And so you could Google those. There's things that you can do like putting constraints on your table to make sure that like, you know, two people can't do the same hotel room at the same time, that kind of a thing, and have the database take care of all that logic. Again, it really reduces like what you have to figure out and do yourself, just doing a little bit of database code and letting it take care of things. So we're all about, man, we're making it easy. Running totals. I wear Crocs. I'm not a big fan of running. I got to be honest. But running totals, I can get behind. I guess in running, I'd probably get behind anybody. Slow. Crocs are not for running. I don't care what they tell you. Let's talk about running totals. So here we have a query. Does this query look scary to you? It's okay. So I'm gonna walk you through it, man. It's gonna be okay. It's all good. All right. I'm gonna give you some data because I think it helps if you can actually see what the data is. Basically, what I wanted to do was imagine I'm running my rental store. People come in to rent stuff, and I'd like to know how much money they have spent with me in the past, right? I want to know if they are like the unusual whale of the rental store, and I should give them like whatever hot discounts or free popcorn or whatever that you would give out at a rental store, or whatever. Yeah, maybe they don't run a lot. I don't know. So I want to get a running total of every time they've come in, how much had they spent previously. And in this case, I do a few little tricks here. So like, just for sort of formatting purposes, I don't actually need to know. I need to know to the very second that they came in and made that payment, but I don't need to know to the 6th decimal second that they made the payment. So I do this little timestamp 0 trick to kind of scrub that away on my payment date. And then obviously I need the amount. So this amount is the amount that they're going to spend on a given day, right? So, and then we do prior spend. Now, how many people here know that nulls are evil? Yeah, okay. That's not enough hands. So it turns out nulls are evil. And we don't want to have them when we write our queries. So I use a little coalesce trick. If you've never heard of the word coalesce, like if you do Postgres for a long time, like it'll just become a thing you say, right? Like, what do you want for dinner? And you're like, I don't know, like I'm coalescing on like Thai or Chinese. Like, it's like probably not really the way it's supposed to be used in a sentence, but you will eventually end up doing that. So here I'm coalescing. So what coalesce actually does is it basically looks in like, I want the first value unless it's null, and then like give me the second value. That's sort of a short explanation for what it does. So here what I'm basically saying is I want to coalesce all of this like some partition thing that we'll talk about in a second, but if that actually gives me a null back, then like just put a 0 in there, right? And it will make sense that that should give me a null if it's the very first time the person has come in, right? They couldn't have spent any money before, so I want a 0 because nulls are evil. So we won't jump into this piece too deeply, but what I'm basically doing is I'm creating a partition on the data, and I'm looking at the preceding row, and I'm just adding that as we go along. I have to order it by payment date because I need it to be in the order. Like normally, as you do like groups and aggregates in Postgres, there's no guaranteed order, so I have to slide this order in there because I really do want it in the order that the person has come in and spent money. If you didn't have that, perhaps those rows would come back in random order, and then it would really make no sense. So I put that in there. And you can see, like, depending on how good you are at math, you can double check that it has actually given you the right data, right? The first time the person came in, they spent $4.99. They had never spent any money before. If we look at the next row, they spent another $4.99, and they had spent $4.99 before, right? Then they come and spend $6.99. Now, previously, they'd done 2 $4.99s, which is $9.98, and on and on and on, right? This is the kind of thing that people do actually get asked a lot. They write a bunch of code for it. They don't actually have to. They just have to write this SQL that probably cannot be generated by an ORM. Maybe it can. I don't know. I think it'd be hard to do that with an ORM. There probably are some that do it. But that's the thing, right? If you wanted to actually look this up later and say, like, how do these rules work on this whole partition over something deal? These are actually called window functions. So if you want to look it up later, look for window functions. There's a pretty good talk by Bruce Momjian that goes over window functions, talks about it. When I have not done window functions, for like 3 or 6 months or whatever, and I come back to it and I need to like do it, in a presentation the next day, what I basically do is I open the Postgres docs to the window functions page, and then I go open up Bruce's talk to the Windows function page, and I looked at both of those, and I can kind of distill what I need into like a SQL query. So I would recommend either of those. The documentation is actually pretty good, but it helps to have his examples and maybe these examples. I don't know. It could happen in there. So again, as you can see, let's talk a little bit more about this. Our sum over amount partitioned by customer ID, right? Because I'm doing this for one individual customer. You do the running total, and you can actually generate, big long lists of this stuff, and it's pretty performant. There aren't too many issues with it. I think people sort of get turned off, like how much analytics should I be doing in my database? Like, is this the right thing? Like, couldn't you just give me all the data and then, I'll process it in Ruby because it's blazing fast? It's actually, Ruby's not blazing fast. If you said you're going to do it in Perl, I might be like, yeah, maybe. But nobody does it anymore. So like I know you'd be lying anyways. So like you're gonna like compute all this data, right? But here's the thing: if I just do these pieces, right? So you're just like give me all the data and I'll compute the running total myself because I'm like a MATLAB whiz or whatever, right? I've got R. Oh, I don't know, or Julia. I don't know what they do these days. Just this piece of the query, right? I select the columns out from payment where customer ID equals $5.99. So just to get the data for the customer, if I were to have run that and done an explain analyze, there's only one small piece of this code that actually mattered. I just left this up here like this so I could, again, harass people who didn't move towards the front. So the cost of this in query bucks, which are not a recognized token yet, but someday I'm sure will be, the cost in query bucks is like 66. Who's going to remember 66 for me? Because I'm going to need that in like 2 slides. Okay, we have a volunteer. So that would cost me like 66 query bucks, right? If I add in all of this piece, right, my magic coalesce and my window function thing with the partition and the over and all that, it does make the query more complicated. You see there's like these 3 additional lines have been added, but if you look at the query buck cost, you see that it's only 67 and our previous number was 66. So this is basically adding like no overhead for it to do all the calculation for you. So don't be scared that like, oh, I'm using like window functions. This is totally going to slow my database down. I mean, I'm not saying it will never slow your database down because like that's how consultants stay in business. But, you know, like there's a good chance you could try this first and see that like it doesn't put a lot of overhead into the system. It's totally safe to use. And I can do this and save myself a lot of application code. So again, I'm just saying, make your life a little easier. Don't be scared. Running aggregate. You have to take it to the next level. That's what we do here. So let me give you another big scary query. So you know it's bigger and scarier because it takes the entire slide. So, but I'm going to walk you through it because it's really not that big and scary. So you've done everything already except for one piece of this. If you didn't realize it, we've walked through all the parts of this query so far. So this first part, the with rented as. Who here remembers CTEs? Good, because it was only, I don't know, 15, 20 minutes ago. So I'm glad we still got that one. So I'm going to name a CTE, rented. And then I'm going to generate a series of dates. Everybody here familiar with generate series? If you are not familiar with generate series, then you should look at this slide because it's got a little thingy that tells you write down generate series. Generate series, most magical thing in all of Postgres. Not exactly true, but it's a function that generates a series. And what's nice about that, no, that's not the right word. What's interesting about that is if you generate, once you have the ability to generate a series of numbers, you can now do loops in Postgres, and in theory can make Postgres Turing complete. That's not what I used it for here, but you could in theory do that. That's a different presentation for a different day. So what I'm using it, there's other versions. So you can generate series of numbers, but there's this nicer version, at least nicer for what we're doing. You can generate series of dates. So I pass in a starting date, an end date, and then I pass in the interval that I want. So this could be like hours or weeks or whatever, right? That are in my series of dates that I'm going to generate. But in this case, I'm doing dates. So I need a list of every day. And the reason why I'm doing this to generate series is if I had a date where I didn't actually sell anything, I wouldn't want to leave that date out of the report, right? So I'm generating a list to make sure that I get every day of the given month. I'm using generate series to do that. Once I have that series of dates, I'm going to do a left join of my actual payment data on the series of dates. I'm using date trunc to do that. Date trunc basically takes a timestamp and then like truncates it for a non-database use of the word truncate to the day. And again, you can pass in different things. This is kind of a weird way to do this, but you know, sometimes that's how I like to roll. It's going to Portland. I said, let's do it the weird way. So we join it on the day, right? Our payment data with the day of the generate series. We're going to do a sum of all of the payments that are on every given day. We call that bucks because that's how many bucks we made on that day, grouped by day. And then, of course, we use coalesce because nulls are evil. Yeah, exactly. There you go. So we use our coalesce trick again to make sure there's no nulls. Again, if we didn't sell anything on a given day, we would get a null back, and we don't want that. So we do the coalesce trick. And then we order it by one because we need this stuff to go in order. what I'm asking for in this query is I want a running total, like we did in the previous query, of how much we've made over the course of the month. But then what I'm also going to ask for is a 7-day average for any given day of how much we have made. So that's going to be like a moving average as we look at the report. So my CTE was the rented. It was all that basic top part. Now we're in this like secondary select piece, right? And this is like further information. So here we're going to do day, and then I'm going to use the operator to push that into a data type. So it's basically doing the same thing as date trunc. It's just different because it's a conference and I have to show different things. Actually, I prefer this syntax, as you can tell, because it's like 1/10 of the letters that you have to type in. I need the number of bucks that we are generating for the biz. And then I'm going to do a sum of the bucks. These are my daily running totals over T. And you're like, what the heck is T? Well, we spilled some tea earlier, but we can't talk about it on a live stream. In this case, I have rented, down below, you'll see where I've declared this window T. So remember, we were talking about window functions. I'm creating another window of data in here, and I've named it T. So this is going over the window named T, right? And it's going to give me my total for the month. And then also, I mentioned I wanted the 7-day moving average. So here we're going to take an average of the bucks that we have generated, do an over on that. And here, though, we're actually using 2 different windows within this query. I know. You're like, what? We can do 2 different windows? We can. So here we're doing a window that is over rows. And the way this kind of works, like it seems really complicated, but it's almost as simple if you don't try to get it out of the docs as it looks. So I need the 7 preceding rows and the current row. So when you think of like what the window is, think of your entire record set as it's coming back to you and saying, I want a window of the 7 preceding rows for the row that I'm currently looking at and the current row, right? So get those. And then when you go to the next row, say 7 preceding and the current row. So just keep moving that window along. I don't use float2 to format this. I use numeric 6.2 because that will actually look like money. That's an inside joke for anyone who saw this talk 5 years ago. It's a really small sample size, but it was worth it, I'm sure. I just want to say, actually, so if an important PSA, if any of you have ever used the money type, I hope that is not a thing. The money type in Postgres is really awful. Should never be used unless you're planning to quit your job and you hate the person who's going to take over after you. But both of those things have to be true. If you're just going to quit and you don't know who's going to replace you, don't use the money type. So you have to hate the person who's going to come after you, and then money type is okay. If you just want to format something to look like money, use something like numeric 6.2. This will put it to 2 decimal places, or use an integer or whatever is nice. Just don't use the money type, whatever you do. All right, that's aside. It's really difficult to work with. It does like weird formatting of data. It tends to lose. It doesn't actually understand what currency is. So like you might think that it does if you say, I'm going to store this as like dollars, and then you're going to like ship your database to another country, or like ship your server or something. Like when you boot it up in that country, if it looked at like, I'm on a different locale now because I did logical replication, like it would change your money to be something else. Like it's broken in about every way it could be broken.
So like you would think you had $10, but it's actually like, oh, actually you have 10 rupees now.
If you logically replicate it over to a server like in Japan, now you got 10 yen. Like it doesn't actually understand that there's a currency involved here. So it's not good. That's all I can say about that. I mean, actually I could say a lot more, but I see people outside, so they're like, we should move on. Okay, so remember rented was our CTE that we started with. And so rented now from rented, because we're selecting this bottom half of the select is all of the stuff that we created in the CTE in the beginning, right? So that's where we're doing it. And then this window for the running aggregate piece of it, this window for the totals for the month, here we're doing rows unbounded preceding. So unbounded means basically go back as far as you can go back. And then I need everything from as far as you can go back to the current row, right? And as Postgres is doing that record set and going down through each row, every time it's going to go back to the very beginning and grab everything in the current row. So you can see how we've got 2 different windows. And if you think about one is like, I need a 7-day average. So I said, give me the 7 rows before in this row. and the other one is giving me everything back to the beginning and to this row. Like you can see how those windows are kind of formed and how they can move along as your record set goes down. What will that record set look like? There's a guy who came in late and he sat in the very last row. You can all turn and look at him and be like, dude, if you'd have got here on time, there's a thing on the very first slide that says we're going to show some code. It's going to have some very small fonts and stuff, so maybe you want to sit closer. But you came in late, and so you didn't see it. Oh, he can see it. So, like, he's hacked the system. He's beating us all. He's beating us all. All right. Anyway, so this is what the report would look like, and you probably actually can't reason about this well, so I want you to get something out of the talk. So here's 10 slices right out of the middle of the thing. So you can actually look at the data. The highlighting is, I don't know what that's for. That's like some weird corporate boondoggle thing. It's my first PowerPoint presentation I've ever given. I've never used this software before. It's fantastic. So here we have a row. So we just take a random day. It's not random because I picked the middle 10, right? I snipped out the first 10, snipped out the last 10 of our 30 days of that we were pulling back. On April 11th, we had done $508.82 in sales. Total for the month at that point was this $5,882. The 7-day average of the dates before this particular day plus this one was $523. And if you look, the main thing, if you're like skeptical of the math here, and you shouldn't be because it's not my math, it's Postgres math. It's way better at math than me. And it's not AI math either, right? Like it's actual computer science math. So you can see the next row, we did less business, right? It goes down to 457. The total for the month still goes up because of course it does, right? The total should keep getting bigger all the time. The average actually goes down because when you put in a lower value, the average should go down. And so you can kind of look if you're watching this like, okay, 500 is less than the 7-day average. So the average should continue to go down. And one of you is good at math and is like, he's not right about what he's saying, but you're not good enough about math to stand up and yell at me. So we're just going to keep going with this. I see wheels turning. So as the totals come in and they are lower than the average goes down. And then you can see towards the bottom, we start getting some big days in there, right? We get that big like 533 day and the average like jumps up a few dollars on the 18th of April, right? Our 7-day average goes back up, as does the total. So again, like we're writing like really complex reports or what people will think is really complex reports. And you're like, it can't be that hard because this dude at this talk at FOSSY, like he was all over the map and he's able to write this stuff. So it can't be that difficult, but it saves you so much computing time and you can answer really interesting questions when you are able to do this kind of stuff that people will wonder about your data. And again, like it's all pretty performant, like just getting the data out versus the extra little bit of, computation necessary to get this stuff. It's very little overhead in many of the cases that you'll try to run this stuff. So would strongly encourage you to look at it. Hopefully you did write down all the little things with the logo. So you can look that stuff up. If you have questions, because I am actually out of time, I am on Twitter. Yeah, that's right. It's still the Twitter app on my phone. So it doesn't work anymore, but it's still the Twitter app on my phone. So I'm on Twitter as RobTreat2. You can email me at rob@exilla. And if you're looking for the video with the variation of jokes from this talk, if you go to pgtreats.info, that is a YouTube page. Warning, it's run by Google, who doesn't do free software the way that some people want it to be done. But those are videos that I have put of like talks I have done on a channel that's at that URL, including this one from like pre-pandemic times. So, and you'll find some mistakes and errors in those slides if you really go looking, I'm sure. So, all right, that's it. I'm out of here. I'm going to push the button, I guess, and not be live on the stream. And then, you're free to go about your day. Thank you, everybody.